This video is on linear equations, but it's really more a conceptual video. It's talking about lines and what a line really is, not necessarily getting into any of the equations yet. Definitely not getting into anything like slope-intercept form, or really, I guess we do talk a little bit about how to create a line, but it's more about the concept of what is a line. So, with that in mind, so first of all, what is an equation? So we've worked with equations already. I'm not sure we've really talked a lot about what an equation is, but an equation it's like a rule that has to be followed. And remember, we talked about equations being kind of like a scale, or maybe even like a seesaw, if you remember a seesaw when you were kids. If you have the same weight on both sides of a scale or of a seesaw, that is in balance. It'll be exactly parallel to the ground. It'll be even. Both sides will be at the same height. If you make any changes to one side, so you take off a certain amount of weight or you take one kid off of one side, in order to keep that balanced, you have to do the same thing on the other side. You have to take the same weight off of the other side, and then it will be in balance. If you add weight to one side, you have to add the exact same weight to the other side. So that's what an equation is like. An equation is simply two sides of kind of like a scale, like I said, the left side and the right side. The sides are determined by where the equal. So in this case, the left side is the x subtract y. The right side is 0. In this other case, the left side is just y, the variable y. The right side is x plus 3. And what we're saying is that the rule is that x subtract y, whatever these two numbers wind up being, they have to equal 0. That's the rule. When you do the math right here, whatever number you get for x and you subtract whatever number for y, they have got to be equal to 0. That's actually how we wind up solving an equation, is because we have to follow the rule, and there's only one way to follow the rule normally. Same thing down here. Whatever number we use for x, y has got to be 3 more than x, because we're adding 3 to x. So with that in mind, let's go to the next slide. Actually, we're not going to go over that slide in this presentation. So if we have that equation, again, the top equation is the one we just saw, x subtract y equals 0. So we said we have got to follow this rule. So I just came up with some values that follow that rule. If x is 0, then y would have to be 0 to follow that rule. If x is 2, because again, 0 subtract 0 would equal 0. If x is 2, then y would have to be 2. And again, 2 subtract 2 would be 0. So all of these numbers, these are just x and y coordinates. I can pick whatever values I want as long as they follow this rule. Normally you would pick x first and then you would figure out what y needs to be, but that's not really important in this particular video. So the point is, every single x and y coordinate, every x comma y, when we plug them in, they will make this equation a true statement. The left side, which is x subtract y, will equal the right side, which is 0. Basically, y is just going to wind up equaling x, because that's the only way that x subtract y equals 0. That's what this second equation means. We could even put this in slope-intercept form. Again, not really the point of this video, but it would be 1x plus 0. Y equals 1x plus 0. All right, so what I've done is I've taken these coordinates, these x and y values, and I've just plotted them on this graph down below. So you see here we have 0, comma 0. Here we have 2, comma 2, which is this second point. Here we have 4, comma 4, and you always go left and right first. And then here, so the last point is 6, comma 6, so I go out to 6, up to 6, and I put a point there. So I've just plotted those 4 points, and you can kind of see these 4 points on the graph. Now we could come up with more values. We could come up with more values for x and y. We could keep coming up with an infinite number of values for x and y. The key is the end result from x subtract y has got to be 0. So let's come up with some more values. So now I've put in 1 comma 1. Again, 1 subtract 1 is 0. I put in 3 comma 3. 3 is my x, 3 is my y. 3 subtract 3 equals 0. All of these values still make that original equation true. X subtract y equals 0. Now I've plotted 1 comma 1, 3 comma 3, and 5 comma 3. I'm sorry, 5 comma 5 onto the graph. So again, 1 comma 1 is here, 3 comma 3 is here, 5 comma 5 is here. Again, I could keep adding more points. I don't just have to use integers. I could use decimals or fractions. So I could use numbers in between 0 and 1, or in between 1 and 2. So let's do that. So I use 0.5, 1.5, 2.5. The key is, once I choose a value for x, I need to use the same value for y, because that's how I get x subtract y to equal 0. So I've just added more points and I've plotted them. So you could, or you should see the pattern now. All of these lines are following the same pattern. X has to equal y. And because they follow that pattern, they all line up. And they form what's starting to look like a straight line. So now let's add even more points, even more coordinates. I've now added in a lot of decimals, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, all the way up to 1, which we already had. And then I've added more and more and more. And then I graphed all of these. And you see that they're even looking more like a line right now. I could do this forever. There's an infinite number of numbers, which means there's an infinite number of values of x I could choose. And as I get smaller and smaller and smaller in the values of x, so like I could do 0.01 for x, which would mean y would be 0.01. And then I could fill in all the 0.02, 0.03, 0.04. I could do 0.001 for x, which means y would be 0.001 for y, and then 0.002 for x, and then 0.002 for y. I could put in an infinite number of points, and every time I plot those on this graph, the space between the points is going to get smaller and smaller and smaller and smaller and smaller until eventually it looks exactly like a line. So a line is not this one single straight thing that we draw. A line is actually an infinite number of individual x and y coordinates, and those coordinates follow a pattern which comes from the equation itself. In this case, all of these points, they follow the pattern that x subtract y equals 0. Or we could say x equals y, because that's the only way to have x subtract y equals 0. So all of the points, and this line would go on forever in both directions. It would go in the negative direction too if we had the rest of this coordinate plane. But every point that we put on this line, x is going to equal 0, or x subtract y would equal 0. That's where a line comes from. All of the points that follow a pattern, and they just get so close together as we use smaller and smaller and smaller values that it just looks like a solid line.